Okay, students, 3.7, graphing cubic functions. Now, the first definition is that inflection point. And in a cubic function, we are still going to use the HK form. So the inflection point will be the HK. And we talked a little bit about this during the previous section when you had to identify all the characteristics. It is the point where the graph changes its curvature. Now for cubic, the parent function is going to be y equals x to the third because they need to have a third power. Now, if you look at the HK form here, students, it's very similar to the point sub form or in the quadratic, the HK form, except now you have a power of 3. We're going to do something very similar to the quadratic. So first, we're going to graph the parent function, which is y equals x to the third. We are still going to pick, as you can see, 5 points that are easiest for us to plug in. But when we plug it in, we have to plug into the cubic function. So -2 to the third power, students, is going to be -8. -1 to the third power is -1. 0 to the third is 0. 1 to the third is now +1. And 2 to the third is +8. Now, HK, which is the vertex, always, okay? I'm sorry, in this case, cross out the vertex. This is a cubic. We don't have a vertex in the cubic. We're going to have a point called inflection point. My bad. And it's an HK. So our inflection point is going to be at 0, 0. We do not have an axis of symmetry, okay? So in this case, we don't have, oh, look, I added that point to cross that out. So let's plot out the -2, -8 is all the way down here. -1 is -1, 0 is 0, 1 is 1, and 2 is all the way up. So it looks just like this. Okay, almost like a lazy, but like an S shape. Okay, so like an S looks like that. But if you think about like a lazy one, something like that. Okay. So the lazy S curve. For this particular graph, your x-intercept and your y-intercept is going to be at the inflection point, so 0, 0. And then both will be 0, 0. The domain is going to be all reals, or we can even write it in interval notation. It's -∞ to infinity. The range is going to be all reals, or again, if you choose to write it as interval notation, it's -∞ to infinity. Now, the entire graph, students, is going to be increasing. So that's going to be from -∞ to infinity. So that's like the same as the domain. So if everything is increasing, the decreasing would be none. The rate of change, because it's not constant, we're going to say varies, and it is a 1-to-1. We do not have any min or max min because we do not have a vertex and also this right here ends, they go up forever. So we don't have a vertex, and the arrows and the ends indicate they go up forever, therefore no min and max. Let's review our transformations really quickly. If A is negative, students, we can say it is a reflection over the x-axis. So reflection over x-axis, or we can even say vertical reflection. You can choose either. Now, we talked about if this A value is in between 0 and 1. Okay, so if A is in between 0 and 1, so for example, like a half or 3/4 or 9/11, okay? If it's positive and it's in between 0 and 1, then it is going to be a vertical compression. Factor of however much that A value is, okay? Now, if A is bigger than 1, such as 2, 3, 9, whatever value that's bigger than 1, even 1.5, that's still going to be a vertical stretch. Vertical stretch. Factor of, if it's a 1.5, then we say factor of 1.5. H. If H is positive, students, you are going to go right H units. If you hear us saying, okay, translation to the right, that's the same thing, or horizontally shifting to the right, that's the same thing. If H is negative, then we can say left H units, or again, if you ever hear any one of the teachers said horizontally shifting, left H unit, it's the same thing, okay? Or we can just simply say left that many amount. All right, K positive, it's gonna go up K units, however many that is. If K is negative, it's gonna go down, okay? Down K units. All right, now if you need to, feel free to pause to write these steps down. Step to graph a cubic function. Identify the parent function, which is different from the quadratic and different from the linear. Make a table of values for the parent. Yes, you want to list out the AH and K because that will help us out. List the transformation from the parent. Make a new table for the transformations and graph the new point, and then you're going to be asked to fill out all of the characteristics. Example 2 and 3 says, identify A, H, and K. List the transformations, then graph and find all of the characteristics. So A for this one, just like the quadratic, A is going to be in front of the parentheses. Can you see that that's a third power? So we know it's a cubic. So A, it's a half. Now H is going to be 4, and K is going to be positive 3. With those three, we can state the transformation right away. I want you guys to make sure you guys are clear on the transformation. With 3, you're going to have 3 transformations since A is positive. Half is going to be a vertical compression factor of a half. So what's going to happen is all the y values, students, from the parent function is going to be half as large. Now H, since 4 is positive, we're going to go right 4 units. And then K for 3 is positive, so up 3 units. Oops, up 3 units. Okay, so those are the 3 transformations. We do have an inflection point, which is an H comma K, so it's going to be 4 comma 3. Now let's fill out your parent function, which is for the cubic. It's always going to be y equals x to the third. Now for the quadratic, the parent's going to be y equals x squared. For the linear, it's just going to be y equals x. So 5 inputs, same exact 5 inputs as the quadratic, but your outputs will be different. Negative 2 to the third is negative 8. Negative 1 to the third is negative 1, just like what we did in the very first example. Now your A value will now change the output, so 1/2 times the y. Right 4 units, so that's going to be x plus 4. Up 3, so that's also going to change all of the outputs. So take your input, I want you to add 4. And then once that's done, I want you to take your time and take all of your outputs. Those will get multiplied by half and add 3. So for the outputs, again, remember you want to multiply by half plus 3. Now let's do the inputs first because that's a little bit easier. Negative 2 plus 4 is going to be positive 2. Negative 1 plus 4 is positive 3, 4, 5, and 6. Now the outputs, make sure you do your basic math a little bit slower if you are not as quick, okay? Negative 8 times half is going to be negative 4 plus 3 is going to be negative 1. Negative 1 times a half, students, is going to be a negative half plus 3 is going to be positive 2.5. 0 times anything is 0 plus 3 is 3. 1 times a half is a half plus 3 is 3.5. 8 times half is going to be 4. 4 plus 3 is 7. Let's plot our transform table. All right, positive 2 down 1. Positive 3 is now 2.5. 4 is up 3. 5 is now 3.5. 6 is now all the way to 7. So you can see the y values in comparison to the parent, okay, it's slightly different. we shift it, we move right, we move up, and not only that, we have the y's. So look at that. So it looks totally different, right? So here's your vertex. Here's the not the vertex, my bad. The inflection point, the HK, okay, inflection point. And let's check to see if it's at what we wrote down, 4, 3. Just like that. That looks about right. Let's find all of the characteristic. We don't have a vertex, so I'm going to cross that out, and I'm going to write inflection point, which we wrote above at 4, 3. Axis of symmetry, we don't have that because we don't have anything that would divide this into 2 exact halves. X-intercept looks like we do have some, but we can't eyeball that, so let's solve it. X-intercept is when y goes to 0. 0 equals 1/2 times x minus 4 to a third power plus 3. First, you're going to move the 3. So if we move the 3, it's going to be a negative 3 now equals 1/2 times x minus 4 to the third power. Now, just like a quadratic or an absolute value, we want to isolate this parentheses. So we have to get rid of the half in the front. To get rid of the half, you can divide by half, or we can multiply by its reciprocal of 2/1. When we multiply by its reciprocal, as you can see, these would reduce. But remember, when we multiply to one side, we have to multiply to the other, just like that. So now on the left side, we're going to have a negative 6, and on the right side, we now have x minus 4 to the third. Yes, it is totally okay to have a negative, and then we're going to take the cube root, just like that. When we take the cube root, if you guys remember from unit number 2, cube root of a negative number is totally okay. I'm going to write a cube root of -1 times 6 equals x minus 4. There's not a plus or minus, so we don't need to worry about it. Now, cube root of a -1 times 6 is the same as saying -1 times cube root of a 6, okay? Now, cube root of -1 is going to be a -1. And then cube root of a 6 is not a very nice number, so we write cube root of 6 back, not -6, my bad, 6, okay? And then we're going to drop down this. Now we're going to add 4 to both sides, so we can put that in the front, or we can put that in the back. That's really up to us. If you put in the front, it's going to look like this, minus cube root of 6. Now, the reason we don't have to write a 1 in the front, because 1 times any radical, it's the same. Now, if you choose to put it in the back, then it could look like this. X equals a negative cube root of 6 plus 4. Now, if you want to put a 1 in the front because you want to, sure, keep it. If you don't, that's okay too. So we have one x-intercept. I'm sorry, I'm erasing the 1. So it's erasing all of that. So we have one x-intercept. It is at 4 minus cube root of 6, or negative cube root of 6 plus 4. Let's write it as an ordered pair. So 4 minus cube root of 6, 0. Y-intercept, it looks like we're going to have 1, but it's going to be so low that we can't really tell. So we have to solve it algebraically. So y-intercept, students, is just like always, is when x equals to 0. So we're going to say 0 minus 4 to the third plus 3, okay? And then we're just going to do some basic math. 0 minus 4 is -4. Now, -4 to the third power is -64. Half of -64 is going to be a -32, and a -32 plus 3 is now going to be a -29. Now, if you can't do basic math right now in your head, that's okay. Just take out a calculator and try to get that calculated. All right, the domain and range for all cubic functions, students, is going to be always all reals. And yes, you can write all reals just like that, or if you like interval notations better, then you can even write from -infinity to infinity. Increasing, this one is going to increasing indefinitely. So it's going to be from -infinity to infinity, the entire domain. That means there's nothing left for you to decrease. The rate of change is going to vary because it's not constant. It is definitely 1-to-1 because it's going to pass your horizontal line test, right? Because any horizontal line that you make, it's only intersecting one time. We do not have any min or max for our cubic function. Example 3 is given to us as y equals a negative in the front quantity x plus 2 to the third power minus 3. Because it is the third power, we know it is a cubic function. So our graph is not going to be like a V or a U. It's going to look more like a lazy S letter. All right, let's list out your A, H, and K. There's a negative, so that's a negative 1. So that's negative 1. H is going to be negative 2. Remember, it's always opposite of that. K is going to be negative 3. With those three, we have 3 transformations, okay? So negative A is going to be a vertical reflection, so that will change all of your Y's. Now negative 2 is going to make us go left, so left 2 units. And negative 3 is going to make us go downward, so down 3 units. We do have an inflection point. It's H comma K, so negative 2, negative 3. So that's immediately, students, you can even plot that right away, okay? All right, let's start with the parent function, x and y to the third. So just like earlier, 5 inputs. By now, you should be able to get the output super fast. Negative 8, negative 1, 0, 1, and 8. The changes, well, I'm trying to move it down. The changes, let's say negative 1 will get multiplied by y. H equals negative 2, so all the x will now be less than that, than the parent. K is going to be negative 3, so subtract negative 3 to the outputs. So just like earlier, take those 5 inputs, take away 2. Then you want to take your output from the parent here and change it by multiply by 1 and minusing 3. Okay, so negative 2, take away negative 2, negative 4, negative 1, take away negative 2 is negative 3, then it's going to be negative 2, then negative 1, and then 0. Next, we are going to negative 8 times negative 1 is positive 8 minus 3 is now 5. Negative 1 times a negative 1 is now positive 1 minus 3 is negative 2. 0 times anything is 0, and minus 3 is negative 3. 1 times negative 1 is negative 1, minus 3 is negative 4. 8 times negative 1 is negative 8. Negative 8 minus 3 is negative 11. So let's plot it really quickly. Negative 4, going to go up to 5. Negative 3 is negative 2. Negative 2 is negative 3. Negative 1, go to 4. And then now 0. Yes, you can always go beyond the grid that's given. So that's right there. So let's see if I can graph this. Oh, I need to go through that dot. Now remember, we have it to where it's gonna reflect it. So the parent function used to go like this, right? So whatever's on the top is now on the bottom, and the bottom's on the top. So that's why it looks this way. So we're starting on the left and we're ending on the right because there is a reflection. We don't have any vertex for a cubic because we have an inflection point. We don't have an axis symmetry. I'm going to write all the stuff that we don't have. How about that? We don't have a min. We don't have a max. We don't have a rate of change because it's going to say varies. Now let's see what we have. We do have an x-intercept. An x-intercept is when y equals to 0. So x-int, let's solve for it. You can't really eyeball it, okay? So you have to solve for it. So y equals to 0. Unless it's already on the chart, but in this case it isn't. 0 equals negative 1 in the front, x plus 2 to the third, and then minus 3. So let's add. We're going to add 3 to both sides. So that's 3 equals negative 1 times x plus, oh, look at that. I missed the 2 in the middle. X plus 2, and then to the third. Next, we're going to divide both sides by negative 1. So we divide both sides by negative 1. Okay, so that positive 3 on the left is now negative 3 equals quantity x plus 2 to the third. Yes, we can totally take the cube root of a negative number. And just like earlier, we're going to say cube root of a negative 3 is the same as saying negative 1 times a 3 equals x plus 2. Well, cube root of a negative 1, we can separately write them like this, but if you don't need to because you know how to do roots, then leave them together. Cube root of negative 1 is negative 1. Cube root of 3 is not a nice number, so I'm going to leave it. Equals to x plus 2. Last step is move the 2 over. So when you move the 2, you can put it in the front or in the back. Is really entirely up to you. So if you put in the front, it's negative 2 minus cube root of 3 equals x. You can stick the negative in front of this if you want to. That's a personal choice. All right, I'm going to write it as my answer, but it's going to be an order pair. So negative 2 minus cube root of 3 comma 0. Y-intercept, it's right here, so that's nice, is 0 comma negative 11. It's going to be all real numbers for domain and range, okay? So, or if you choose to write interval notation, it could look like that. It's definitely not increasing, so NA for increasing, but it is decreasing the entire time because as you can see, Y is gonna get less and less. So it's gonna be decreasing the entire domain interval. So that's gonna be negative infinity to infinity. It is always gonna be a 1-to-1 for a cubic.